Qualcomm's main point is that they're diversifying their businesses, and the majority of their business in the long run will be non-communications. And I thought this was interesting because the name of the company and the legacy of the company is communications, quality communications, Qualcomm. But the crazy thing is the data center business could become so big, and it could inflect so much that what Qualcomm makes from their new businesses, data center and automotive, could ultimately dwarf what they make and have made in the aggregate of the company's history as a communications player. So that's something big to wrap your head around, which is just Qualcomm being a communications player could just be the start of their story. All right. Hello. Welcome, listeners. Welcome to another Semi-Dope podcast. I'm Austin Lines with Chip Strat, and with me is Vic from Vic's newsletter. Hey, Vic. What's up, man? It's been a while since we chatted.
Yeah, it's been a while. I've been traveling, you've been traveling. Finally, we're back at the home studio. So it's time to do something now.
Totally. So you were in the UK and it was hot?
It was crazy. I thought I ran away from India to get away from the heat and feel some cool air in UK because everybody says, oh, it rains all the time. So I was hoping to get like rained upon a little bit. But anybody listening from the UK will be like, no, you'd never wish for that stuff. Don't do it. You know, we like a little bit of sun once in a while. I know it's like a lot of sun right now in Europe, but it's okay, maybe for a week or two.
Yeah, totally. Yeah, I saw it was like 110 degrees Fahrenheit or something in France. Just like when you said it was hot, I was like, oh yeah, it's like UK hot. But it's like, no, dude, it was hot.
It was hot. And you know, the other thing is in the UK, they're not just equipped to deal with this stuff. Because in India, like either there's AC in some places. If not, if you go by buses, for example, there are like windows. Sometimes there are no windows. Okay, so you always feel the breeze. It's not cool breeze, but at least there's movement of air.
Sure.
In the buses in the UK, it's just like sealed. So there's no air movement. The windows don't like open out or slide out or anything like that. And you're just trapped. And you just have a bus full of people just like sweating. It's a sweat lodge.
Just suffocating. Yes, brutal. Well, I was in New York City and Qualcomm flew me out for their Investor Day event, and the weather was really nice in New York City. It was very beautiful. I woke up early. Obviously, the sun's out for a long time right now. I ran in Central Park. I ran one day to the west side along like the Hudson River. I saw crazy huge yachts. I have never seen such big boats in my life. I don't know if it's like someone who lives there's yacht or if it had to do with the World Cup because there's a bunch of people in town for the World Cup. But it was like, I was like, dude, you need a whole staff to run this thing. Like, this is crazy. And here it is. And I'm just right by. I was going to take a selfie in front of it, but I thought like, I don't know. That seems kind of touristy.
I mean, all the investment bankers live there, right? Like half the people who listen to our show must be their yachts. Maybe they should let us know.
That's true. Hey,
Austin, you saw our yacht.
Live semi-doped podcast from your yacht. You send it to me. Austin at chipstrat.com. Send me an email and we can chat. Okay. So,
right, so wait. You were at in New York for the Qualcomm Investor Day then?
Yes. Qualcomm Investor Day. I was there. Obviously, they host it in New York City because the audience is the sell side analysts and the financial community, but they brought out industry analysts as well because they had a lot to talk about. So really the story that we'll walk through, and I want to talk through the technical bits and hear your take on some of it. The story that Cristiano Amon and Qualcomm were trying to communicate was all about their diversification, which away from handsets, which ultimately Qualcomm has always been, a communications company, big smartphone business. Everyone is seeing the writing on the wall with smartphones, which is just, we're at the top of the S curve. Everyone has a smartphone, right? There's lots of competition in the space and so on and so forth. Qualcomm has been moving into automotive and that business has been growing. And it's a proof point that, hey, they can use M&A to get into a new business and then build the technology, use their channel, use their manufacturing scale to grow that business and take it to market. And the whole point of this was Qualcomm trying to say, we are going to do that with data center as well. And here's our plan. And so ultimately, we'll include this, the image, but like they had this sort of one money slide I think it was from the CFO's presentation where there was like three circles. It was like a donut ring slide. And they were showing like, okay, in fiscal year 25, handsets were 2/3 of our business. Automotive and IoT is 1/3. Our goal for 2027 is like roughly half and half handsets, half other, which now starts to include data center. And then fiscal year 29, the goal is actually 2/3 of the business is automotive IoT and data center, and only 1/3 is handset. So they're trying to move sort of beyond their legacy communications only business and move into these other new businesses. Which last point, and then I'll let you chime in. Obviously, communications is part of all of these businesses. So it's the IP and the technology is still important to the other businesses. It's just that they're going to have to build more and do more than just handsets.
So I saw the whole Investor Day talk. I wasn't there, but I saw it on YouTube. It was interesting because Cristiano Amon said that for the 40th anniversary of Qualcomm, they had the founder over, Irving Jacobs, and during that conversation or the talk that he gave, he mentioned that he made one mistake in naming the company Quality Communications. He's like, I should have just stopped with one M in the com, because now it could be Quality Compute. But now it's a problem. So they're going to.
That's hilarious.
In my opinion, they should rebrand it and drop one M.
Totally. That's yeah. If only he had the foresight to think 40 years ahead, right? No, that's so funny. That's so true.
Yeah. So that's the big deal. What you say is actually a big deal, because this company from the get-go has always been about communications. They have a rich history. It started with like satellite communications. And when I joined there in 2018, they had a tour of the museum within the campus that showed the entire history of all their devices that have been made from the beginning, So it's really nice. As part of the orientation is that they take you to museum of their parts. It's a very inspiring way to start working there. But that's the legacy, because they've been through 3G and 4G and 5G. They're also on the 6G train. We'll talk a little bit about that. But now they are saying that only 1/3 of that business is going to be handset based, which is a way of saying that's communications business. 2/3 will be IoT and data centers. It's a big shift.
Indeed, it is a big shift. So let's start with maybe the confidence question, which is, do you think Qualcomm can get into new businesses? Maybe we'll start at the top there, kind of strategically high level. Do you think they can build a real data center business? I'm going to let you have your take, and then maybe I'll provide some color of what they said as well.
They can, because there is no reason a company like Qualcomm cannot get into data center business, because they have compute. Right? They have the CPU business, they have NPUs, which they use graphics acceleration on their SoCs, mobile handsets anyway. They have all kinds of IP now through the Alphawave acquisition. I was looking at what all they got through that. And it's quite a lot, actually, because they have SerDes IP in copper and optical. They have PCIe Gen 6, CXL for like servers and storage stuff. Then they have Ethernet IP, 800 gig, 1.6T for like switches, routers, DPUs, NICs. And they have like HBM and DRAM IP for GPUs, which is very, very important. We'll talk about that because that's one of their key technological innovations in the era of AI and the way they are doing inferencing chips. And they also have chiplet IP through the Alphawave acquisition through like UCIe or bunch of wires or other standards like this. So they are very well positioned as a company who has also shipped like billions of devices into handsets world over. So it's not like they are new to doing this. I could argue that if OpenAI says like I'm now a chip company, Anthropic wants to be a chip company, they have never been a chip company. It takes experience to be one, which Qualcomm has. So yeah, they are well positioned to do so, although one could argue that they are a bit late to the scene.
Yes. Okay, so let's get into that. Now in the grand arc of things, late and timing's interesting because, obviously this has been going on since late 2022, but it's only 2026. And this is the type of technology that will be here for the next, 30, 40 years, whatever, forever. Right. And so, being late now feels like a big deal. In the grand arc of time, it'll just be a little blip. But the question is, if you're going, what does it take to succeed? Which I think you hit on nicely, which is you need to have IP, you need to have talent, you need to have manufacturing prowess, and you need to have technological differentiation. It can't just be a me too fast follower, like, oh great, a company did this, I'll build the same thing and sell it into a different market or something, right? Like that's not going to work. Like there has to be a reason for a customer to choose you. And then to the point of being late, you especially have to differentiate on some vector. I think of when I think of NVIDIA's, Hopper era GPUs, and then eventually AMD came in with Instinct. And what was nice was they made a different decision about the amount of HBM capacity that would be on a single chip. And that small decision on one vector opened up some particular workloads that could run on like 8 Instinct 300s, I think, or maybe it's 350. I can't remember off the top of my head. But it took 16 NVIDIA GPUs because they just didn't have enough memory capacity on each GPU. And that illustrated for me that like, even if you come in late, if you make some sort of different technological bet, it might unlock a certain set of customers, which can help you get your foot in the door and grow from there. And so I think to your point, and as we'll get into, Qualcomm checks a lot of the boxes as far as like they're a big company, they have experience, they have IP. Oh, and by the way, they were able to use M&A to get IP that they didn't have, get talent that they didn't have, and kind of fill those gaps, which is something we've seen them do before in their automotive business. We could talk about that, but it's beside the point a little bit. But there still needs to be something different so that at the end of the day, a customer like a hyperscaler or an AI lab will know why they want to choose Qualcomm. And it's not just because it's cheaper, or it's not just because everyone's out of supply and Qualcomm happens to have some. None of those are sustainable. Those are temporary, but there has to be a technological differentiation that really impacts ultimately like TCO for a particular workload. And this is even why we saw like the Groks and the Cerebrists have success, is because they made design decisions, and there was lots of sort of negative consequences, but for a particular workload, high interactivity, it was much better than GPUs could do. And so obviously Qualcomm had to come out swinging and say, we think we can do something different here.
Yeah, their key differentiator here, apart from their memory architecture, which we will discuss, is basically the fact that inference now is getting disaggregated. This was their key theme that went through the whole talk, because they kept saying this is now disaggregated, which means that you can actually develop hardware to do a particular task. So you could put in a Qualcomm rack along with some other racks. It doesn't mean that, you have to fill NVIDIA racks with, all these Blackwell GPUs along with their Vera CPUs. You don't have to do that. Now you can put a rack full of CPUs separately. You can put a rack full of low latency decode, like you were saying, the Cerebrus or the Grok LPUs. And now you can put maybe a rack of Qualcomm inference chips just to do that one portion of it. If they have a high memory bandwidth, you could just do decode on that if you want to, and still continue to use maybe NVIDIA GPUs for the prefill part. So the disaggregation across the whole inference space, which is becoming more and more a theme, because one size does not fit all. You've spoken about this in your Substack as well. Like there is a right-sized hardware for the right-sized workload. So that is increasingly becoming a theme, which is why you can run different kinds of hardware along a common software platform, which Qualcomm also wants to have, open and developer-friendly for everybody to work with.
Yes. You're totally right, which is disaggregation has really opened the door to everyone. Once we started to break the workload down for inference, today LLM inference is obviously the defining workload. The value is actually all being created by agentic inference workloads, so reasoning models. But in breaking up that workload into inference and decode, then people could say, okay, I'm late to the market. I'm just going to focus on decode. I'm going to do something very decode specific, and it's going to be very different, and that will help me get my foot in the door. Again, worked for the AI ASIC startups, and this will have to be the mindset that Qualcomm has, because ultimately, yes, would they like to sell data centers full of Qualcomm Dragonfly, which by the way, that's what they branded it for anyone who's not watching. Dragonfly is like their data center brand. Would they ultimately like to sell in the branding was white and gold, by the way, so it looks very nice. So would they like to have a data center full of white racks so that whenever on FinTwit you see a picture of someone saying, "Look, I built a data center and all the racks are white," everyone can go, "Whoa, Qualcomm to the moon!" Yes, they want to do that, but the reality is, which I think that they're very fully aware of, is they need to sell like a few racks into the existing data center that's full of NVIDIA GPUs. And so trying to focus in on decode, for example, would be one way to get there. But okay, take us further. Let's talk. Do you want to talk about the memory, the HBC? That was sort of like the big star of the show.
Yeah, let's go to HBC because that is an underlying technology that is very useful regardless of whether they want to use it in data center hardware or IoT or automotive or robotics even, because this is going to be the platform that lays the foundation for all of their businesses going forward. In my opinion, it seems like that way, at least from what I heard. So high bandwidth compute is their way of getting a better memory bandwidth hardware packaged right next to an XPU so that you can get a really fast inference bandwidth like you would get with, like Cerebrus or Grok LPUs. Because those things can do like SRAM bandwidth is in the range of 100 terabytes per second. And right now, HBM bandwidth is about a tenth of that. It's about 8 terabytes per second, right? So they want to break through this 8 terabyte barrier, which currently involves an HBM stack sitting next to a GPU or XPU and connected with maybe 2,000 lanes of interconnect between the two memory and the GPU chips. And it is packaged with an advanced packaging substrate like TSMC CoWoS, right? So their idea is with high bandwidth compute is that you take the memory and you put it on top of the XPU die. And instead of connecting the memory through the side using, on the shoreline density, as it's called, on the one edge of the GPU die, you can only put so many lanes before you run into advanced packaging limits. If you put the memory on top of the XPU, you expose the entire face of the chip between the XPU compute and the memory to have interconnects. So now you can put, instead of 2,000 lanes going through between these chips, you can have, tens of thousands or even 100,000 different lanes. So what that does is, if you increase your bandwidth number of lanes by 100x, you'll get 100x more bandwidth kind of thing. So this is their main idea of doing what they call high bandwidth compute.
Yes. Okay, and so there's so much to unpack here. So I'm going to walk it through again for people at a high level in case they didn't catch it the first time. Because I will be honest, one, the naming might not do it justice, although I don't have a better name, because HBC, HBM, it feels very similar, but there's actually a lot of differences going on. And then two, there's actually some nuances that, again, weren't obvious to me like the very first time it came across, but as I looked back at it again as we prepared for this episode, there's some things that stood out, so I'll talk about it. So one of the problems, obviously the way everyone knows, the way GPUs and HBM work today is you've got the HBM, it sits next to the GPU, and you've got things like weights or activations, whatever, KV cache stuff sitting in this HBM. And during decode, especially, that stuff just has to fly back and forth. It's like if you separated like your kitchen and you put your fridge in the garage and you just had to walk to the garage and get something, bring it back, chop it up, walk to the garage, get the next thing, bring it back, chop it up, walk to the garage. Obviously it's like, dude, what are you doing? Why are you spending all this time walking back and forth to your garage? Just put your freaking ingredients right next to your chopping block, So, because of course there's lots of power loss, lots of latency time, that kind of thing. And to your point, you can't, the analogy breaks down, but you can't get as many lanes and as high bandwidth. So one point is ultimately like, how do we bring the compute as close to the memory as possible? And other people have called this like near memory compute, processing in memory, stuff like this. There's lots of startups doing this. I think is D-Matrix doing something like this?
Yeah. This is D-Matrix approach, what they call in-memory compute.
In-memory
so
compute.
D-Matrix also puts memory on top of logic. So there is a question of really, is the Qualcomm innovation all that different? Is another question to ask.
Totally. So that's the first problem is how can we bring the compute as close to the memory as possible? And so what you said is like, oh, well, what if you actually like the closest thing is to stack the memory on top of the compute and just literally have it as close as possible. Now there's obviously thermal concerns there. These GPUs, XPUs are like crazy hot. So can you actually put memory on top of the XPU? And as I looked closer in it, and we'll try to include some pictures as well, my understanding is they are not actually stacking the memory on the XPU, but they're putting a logic chip under it, and they're putting it close to the XPU, but they're actually offloading some of the workload to live on that logic chip. I don't even think it's necessarily like a programmable logic chip. I have a feeling that it's almost more of a true accelerator in the sense of accelerator. And so, for example, like my guess would be like maybe you have during inference some sort of primitive, some sort of function that's run all the time, like softmax or something in attention. Can you actually take that off the XPU, put it in the logic that's right under the memory? And the idea is like, fetch what you need from the memory, do those primitives right there, and then send the result back. And that would obviously help you solve like the thermal issue of you're not actually putting the memory on top of this crazy hot XPU, but you're still using advanced node logic and putting the memory on top of it, and then just accelerating an even finer grained piece of the workload. And so again, and I'll let you jump in because I know you'll have thoughts and reactions on if I'm interpreting that right. This would be the name that we've always used before AI, which is like an accelerator. So like a camera, like an image sensing processor or any other little like acceleration that we've done in the past, like with graphics, which is you're like, dude, we just keep doing this particular loop over and over on a CPU. Why not build a little, Qualcomm does this all the time in their Snapdragon SoCs, like build a little thing to do some image processing that's just dedicated for that. And my understanding, it felt conceptually like they're saying that, take a little tiny piece of the inference sort of primitives, move it off, but then also it's very important that it's very close to memory because it's very sort of memory bandwidth intensive. So I'll pause there. What is your reaction?
So when I saw this being announced on the talk, it was very confusing the way it was drawn out, because in the first example where they show how the current solution works, they actually had a GPU and they had an HBM there, and there was like this gold colored like back and forth happening. It was very beautiful to look at, and you could see that data was like this gold data was going up and down the HBM stack and was like going around into the GPU. So that's how it works today. But then when they put in their solution, which is basically their high bandwidth compute, they showed a stack of LPDDR, and then they said something about XPU, okay, and then sitting next to it was an SoC, right? And then they were showing the same gold thing, which presumably is data, going between the SoC and the LPDDR stack. So for somebody who's looking at this, it looks very similar to the HBM one. I'm like, what's different? And then they go on to mention that, no, you don't need advanced packaging anymore, that you could do standard packaging because you don't need that bandwidth anymore. So my interpretation of this is that it's not really the logic die under this memory is not really any simplistic logic die of any kind. It is a full up XPU, right? Because that's the only way that you will not need advanced packaging to make this work. You have to do the full thing there, and that's what D-Matrix is doing. They do all their compute right under memory.
Okay, so when you say XPU, what is your definition of XPU then in this particular use case?
This is the thing that does matrix multiplications. That's what I call an XPU.
Yeah. So do you think they will do any matrix multiplication anywhere in the workload right there under the LPDDR?
Yes, I think so. It's going to me, it looks like it's very similar to what D-Matrix is doing, because D-Matrix, digital in-memory compute, and their Raptor, which is the next generation of 3D DRAM, which they call 3D DRAM, those slides are out in there. They previously announced this stuff, so it's nothing that's unannounced or anything. They actually have a full-up XPU chip that it does all the compute under the DRAM die, and that's it. That's their Raptor chip. So this has to be something like that.
Yes.
This SoC sitting next to it is doing something else, right? It could be a mobile SoC. Like if you're using AI on a phone, it could be a mobile SoC. If you're using AI in a car, it could be an automotive SoC. But it's not doing matrix multiplications. It's doing SoC stuff.
Sure. I mean, so I agree with you. Like conceptually, the idea of essentially like a tensor core coming and moving over and doing all the matrix multiplication, I totally agree that's what makes sense. That's what you would want to do, is get all of this multidimensional data, put it right down into some sort of like tensor core type thing and have it do all the matmul's. It would be nice to understand the clarity of what else is in this SoC. Obviously, right there's die-to-die communication. There's orchestration of the whole workload. There's communication with CPUs. So there's all these other sort of like blocks, if you will, that don't need to live right there. But I do agree with you that it seems like conceptually anything in the workload that's related to the specific matrix multiplication stuff would live under the memory.
Yes.
And you mentioned earlier that this technology could actually come to the edge, come to phones, come to auto, come to wherever. And I think that's also the key point here, is if people think like GPU with LPDDR stacked on top, then that might be a little confusing, because it's like, oh, are we putting big GPUs into a car now? But the point here is that the technology, the concept of the technology, which is if your car is going to run neural nets, wouldn't it be nice to have the matrix multiplication under a big stack of not HBM, but LPDDR, something that may be like lower power, cheaper, higher capacity, but that would still let you do essentially generative AI at the edge, presumably with even bigger models, for example.
Yeah. I want to talk about this memory stacking part first, because
yes, please.
We will definitely talk about the automotive IoT and the robotics aspects, which they really want to get into in the future. And I think they're well positioned to do it. But there are like several issues with the way this memory works to begin with. First of all, you already mentioned the thermal aspect. It is pretty challenging to stack logic on top of GPUs or XPUs like this. The second thing is that there is a fundamental size mismatch, right? These XPUs that sit under any form of memory, like even when D-Matrix does their Raptor, they are pretty big dies because they are reticle sized GPUs that sit there, right? Because NVIDIA's even like packages multiple GPUs in a single Rubin or whatever nowadays. So it's easy to assume, and it's okay to assume that the XPU will be a reticle sized compute unit, which means it's like 850 square millimeters, or anyway, it's above 800 millimeters squared of chip. Now, if you have to stack DRAM on top of that, can you imagine how big of a DRAM die you need to put on this chip? And can you imagine the planarity requirements of actually hooking this up and keeping it planar in a thermal environment? Like stuff is heating up, and the planarity between the top die and the bottom die needs to be maintained across without having the bumps rip off each other. This is a challenging problem.
Yes. You're saying that like things move and warp and whatnot when it's hot, but obviously you need physical connections, wires, pipes, so to speak, going up and down. So you can't have all this moving and the pipes moving around. Like it needs to be all kind of rigid, stable, heat up together, cool off together,
Yes.
or dissipate all the heat so that it doesn't move around.
Yes, yes. So it's a challenging problem. And as much as they say like, oh, we don't need advanced CoWoS packaging anymore, yay, we solved packaging. It's okay. It's enough to use a standard pitch package for this. They have not really solved the packaging problem. Okay, they moved it to a different place. They moved the packaging problem from next to the XPU to on top of it, which is arguably even harder. And one more thing I want to point out is that the picture deceivingly shows you like multiple LPDDR stacks. Okay, it's not that easy because even the Raptor first generation is probably going to have one die layer. Okay, the expansion is going to happen later. People want to stack more DDR die on top of each other, but it's not simple by any means because as it is, it's hard enough to stack one memory chip on top of logic like this. Okay. Because like this is like logic on logic stacking in a sense, if you think of it like that. It's like stacking SRAM on top of compute, like AMD did with its Vcache. Similar stuff,
Well,
right?
yeah. Okay. Well, talk to me about this then. Okay. So obviously, Qualcomm's going to need to work with a memory vendor, but then there's a logic accelerator under it. So they'll obviously have to work with like the logic foundry as well. And
TSMC, yeah, sure.
TSMC, exactly. Then as far as like the thermals and the stacking and making the logic and the memory sort of behave nicely, like ultimately, who does that fall on? And HBM4 has, or maybe it's HBM4E, has memory, HBM stacked on top of a custom logic die now. So I'm wondering if some of these thermal problems are already being solved for HBM4 stacked on, like the HBM stacked onto custom base logic die. And if there's any like learnings that can be applied here. So it's like, oh, the industry has already solved this. Or is it like, no, we're talking about different memories and a different level of compute under the memory.
I don't think that the logic die and the HBM die sizes are as big as a GPU die. They are smaller.
Oh, true,
right?
true. Yes.
So that's what I was pointing out earlier, that it's not as easy as that. Now, if you want to stack something the size of a GPU die, that's difficult. So the logic die under HBM4 are smaller, and they don't nearly do as much work as something doing matrix multiplications to infinity, which is what XPUs really do. They do a lot of matrix multiplications. So it's like a computationally much more heavy workload when you try to do it under.
So presumably running hotter for more often.
Yeah. There's another catch to this. When you do DDR7 on top, let's say, I don't know, a DDR7, LPDDR on top of LPDDR, the whole idea was like DDR has more capacity than HBM per layer, right? And therefore you're getting more capacity. No. But now when you stack DDR on top of DDR, that's pretty much HBM. Now what you're doing is you're stacking HBM on top of compute, in my opinion. And the reason HBM per layer does not have that density, memory density, is because there are through silicon vias. And when you have through silicon vias, you can't put as much memory cells around it. There's like a keep out zone. If you put a through via silicon via here, you can't put memory cells around it through some distance.
Sure.
So per die, your memory capacity drops, right? So you get high density if you stack only one layer because you don't have to put vias through that memory layer. The moment you start stacking two or more, you will have to put vias through the layer, and which means that the capacity per layer will start to drop, right? Let's say by half. And so you need to stack like 4 to make it even useful. You can't stack 2 because you lose it on density and keep out regions. So you see the complexities here that nobody ever like talks about. They just say, look at this, yay, high bandwidth compute, let's go. And that's it.
Totally. On that point, this was obviously an investor day, and so they teased some technology, but they didn't get into the technology weeds. I would love to see Qualcomm have a like data center day or something that's focused on like the technical architecture and all the technical details, or ultimately just publish some papers on this, show it at Hot Chips, whatever, because there are lots of technical questions, but if they can answer them and answer them confidently, then it gives a lot more credence to what they try to say at Investor Day, which is, we're late, we've got a new approach, we think it can ultimately be competitive, it's HBC, and we've shown you all the technical bits and answered all of your questions with satisfaction, so you can believe that it's possible, it'll work, it'll scale, it's and so on and so forth.
Yeah. So I think we've spoken about the technical complexities of HBC. We don't know any more details, like you say, unless they publish something. But I think the first HBC-based chip is expected in 2027, that's what they said. And then they showed a chart that shows that they will do the AI 300 in 2028, and they will use like UA-Link and eSUN for scale-up fabrics, right? And then somebody in the audience asked, like, when are you doing scale-up CPO? Or CPO, right? Obviously, CPO. They said, yeah, it's going to be after that. So it's like maybe a 2029 thing would be CPO. So it's interesting that this is in the works, but we really have to see the silicon show up for us to understand anything more than what it already has been announced here.
Totally. So on the accelerator roadmap, so they said, yes, we've got a multi-generation accelerator roadmap. Historically, they had the AI 100. That was kind of like whatever. It was a long time ago. Maybe, I'm sure they learned some lessons, but you could argue it doesn't really count. The AI 200 sampling in 2026, it does not have this HBC that we're talking about. It is the AI 250 that has the first generation of HBC technology, and that's in 2027. And then, to your point, the AI 300, which isn't until fiscal year 28. And you would know, when does Qualcomm's fiscal year start?
It's a good question. That? I never followed the financial side of things when I was at Qualcomm. I was doing engineering work. No, but I think it starts in 2027, actually. When you say financial, because why I said that is at the end when the CFO was talking about FY 2027, and he just mentioned, hey, FYI, that's actually in calendar year 26.
Yeah, so right, exactly.
1 year
I
earlier,
think yeah. Well, I don't know if it's a full year, but it's probably like it starts in June or something. It
starts in the later, part of the year.
Qualcomm fiscal year start. I'm Googling it, audience. Qualcomm's, according to AI Overview, Qualcomm's fiscal year begins on the last Sunday of September. So they kind of pull it forward by a quarter, essentially.
Yeah, right.
Okay, so...
I did pay attention a little bit.
So the AI 300, that's when they get the second generation of this HBC. That's also when they add, scale up, UA-Link or eSUN, and copper and optical scale out. So they started to have the buzzwords. And so I think this is like a nice transition to talk a little bit about Alphawave Semi. So one of the things nowadays, if you're coming to compete in the data center accelerator market, you can no longer say, I have a chip. You have to say, I have a rack scale solution, which not only means the accelerator chip, but it means the interconnect. So obviously going all the way back, NVIDIA bought Mellanox, and that was their way of using M&A to say, we want to be more than just the GPU. We want to do the whole system, and Mellanox gives us all the networking, scale up, scale out, switches, all the good stuff. So then the question is, what is Qualcomm's Mellanox, so to speak? And Alphawave is an acquisition that they made, I think about a year ago, maybe a little bit less. And Alphawave historically is well regarded for their IP. So a lot of communication IP, you mentioned it earlier, and we can get into it a little bit more, from SerDes, and essentially taking an accelerator and making it able to talk at high enough bandwidth and get data in and out and communicate in and out, I should say, with sort of industry standard networks, talk to, like, say, a Broadcom switch on the other end or whatever. I will also mention that Alphawave Semi actually also brings custom silicon customers to Qualcomm, because Alphawave was pretty smart, which is to say, hey, if we're good at the hard part, SerDes and I/O, we can help people do custom XPUs. I mean, that's essentially like what Marvell does and what Broadcom does. It's saying, like, we could license you the hard part, or we could say, like, no, we can also do the quote unquote easier part, like the front end RTL stuff. So Alphawave Semi was actually also in the game of custom XPUs. So not only did Qualcomm acquire the IP and the talent, but they also acquired customer relationships and like already like roadmaps that Alphawave Semi had with these huge hyperscalers. They didn't name them. They said there's two. And then also separately on the call, they had Satya Nadella spoke and Mark Zuckerberg spoke. So obviously that implies that Meta and Microsoft are working with Qualcomm on data center, but they did specifically call out two custom silicon customers, which are presumably heritage legacy Alphawave ones. And I didn't think about this until just now, but Alphawave was public, so a person could probably go back and look and figure out who those customers are.
The CFO also said that they expect $1 billion of revenue in 2028, I think, where they said that the total revenue would be $5 billion. But $1 billion will come each from one of these hyperscalers. So
nice.
$2 billion is already spoken for. I don't think it's actually Alphawave's customers, because he said that on top of this, we have like the Alphawave business as well that will add on top of this. So he says, yeah, things are looking very good. That's what the CFO's whole thing was. But talking in terms of acquisitions, actually their modular acquisition that was recently announced is very interesting too, because you can't build all this stuff, a rack scale solution, without providing a software layer to go with it. And basically that's exactly what Modular brings to the table. They have something called like Mojo, which is somehow equivalent to NVIDIA CUDA, I suppose, in the programming layer. Then they also have something called Max, which is the equivalent of like a Triton or TRT LLM, which is for model serving. And then they have the cloud one, the cloud product, which is distributed. It's like NVIDIA's Dynamo. It handles like KV cache offloading, I suppose, and data movements and all of that stuff. So Modular is basically that you can use this software layer to run what they call multi-silicon token factories, which means that this software layer will tie together hardware from multiple vendors in a single solution so that you can mix and match. So that's a powerful thing where Qualcomm solution can be slotted in with others and still work.
Right. So this is like the unicorn that everyone's always talked about, which is like write it once and run it everywhere. But actually, when you peeled it back, there's always trade-offs of like, oh yeah, you're writing in some high-level abstraction, and then something's happening, and it's trying to like, translate it down to something that runs. And usually what happens is things are like unoptimized. There's a translation layer higher up and it's unoptimized. And so the natural question is like, okay, is this different? And actually, this was a very surprising and strategically good decision by Qualcomm, because Modular is started by Chris Lattner. He's one of the co-founders, and he is sort of like a legend in the space of compilers and programming languages. When he was in his PhD, I think he created C-Lang compiler and LLVM. When he was at Apple, he invented the Swift programming language. And he also has history with MLIR compiler. And at the end of the day, what Chris and team did is make it so that you can build I think if you use their language, it's like a superset of Python maybe, but they have the hooks to go all the way down to like MLIR. It's like multi-level intermediate representation or something. So to kind of go way down the stack and hook in there. And so like at the most high level conceptual level, I would think of it as like other approaches that it's like, yeah, right, using our software and it'll run on NVIDIA's and ours, would have to do some translation stuff at a much higher level, and it was unoptimized. And Lattner's team is able to go kind of like much further down the stack. So ultimately, in the data center, this would be great, because you could say, hey, use Mojo, use Modular's tools, write it for the Qualcomm, and it will also run on NVIDIA. Now, Chris has before said that they can actually squeeze more performance out of NVIDIA's chips than NVIDIA. So it would be like, we can also make sure that you're getting as much as possible out of your existing NVIDIA infrastructure, potentially maybe even more. So that's compelling. But then another really compelling angle is just Qualcomm infrastructure to say, hey, what you deploy in the cloud on Qualcomm hardware or someone else's hardware, you could also deploy on premises. You could also deploy on your desk. You could also deploy on your phone. So that's interesting too. It's not just cloud multi-vendor silicon that you could deploy across, but in theory, you could easily deploy across from cloud all the way to edge, but not obviously NVIDIA is doing that too, where they're bringing right with their laptop and stuff that they've come out with recently to say like, oh yeah, you can write CUDA and it can run in the cloud, or it can run at the DGX little box on your desk, or it could even run on your laptop. But that is still a proprietary environment. And so if you use Mojo and Modular, you would be able to get all those same benefits, but in a true open kind of modular, hence the name, environment.
Okay, so that's good about that. We should move on and quickly mention what they called for their CPUs for data centers. They call it the C1000, and it's supposedly a 5 gigahertz per core and 250 plus core count, which is like runs a lot of PCIe Gen 7 with LPDDR and all of this. I think they have like 3 different versions of this. One for agentic CPUs, one for general purpose, and one for AI head nodes, which is nice. And it looks like they had like Mark Zuckerberg come in and do a video clip saying that like Meta is planning to deploy the C1000 in the data center, and that they have a multi-generational agreement to supply to Meta. So good, they already have like a business customer there in Meta. But the one question from the audience at the end on this topic was like really funny, because that analyst asks, hey, your CPU is like for 2028 or something. It's not like this year. So the analyst asks like, hey, you say like 5 gigahertz, but is your CPU any good in 2028? Like now I know everybody knows there's an agentic AI CPU shortage now, but you don't have a product for 2 years. What's with that? And so for that, the Alphawave CEO, Tony Pialis, right? His name was?
Yes. Yep.
Yeah, he was like, oh yeah, Qualcomm has engineers, like the best engineers. And so when they design stuff from the ground up, it doesn't matter. When it hits the market, it's still going to be the best. I'm like, dude, I mean, I thought Amon was like the bullish Qualcomm guy, which makes sense because he's been a Qualcomm guy since he was an engineer, and now he's CEO. So I'm like, Tony Pialis like showed up like 6 months ago with the Alphawave acquisition, and I'm like, what's with the bullishness about CPUs? I don't know. I can't be that bullish, okay? I'm going to say that. I'm going to take that with a grain of salt. It's good. Maybe we still need CPUs. I don't think we are anywhere near the peak of what hardware is required for AI, agentic AI and all that. Maybe CPUs will be required for another 5 years. Because if you see like AMD's forecasts, there's like a massive growth of the CPU industry all the way to 2030, 2031. So in a sense, yeah, I buy that Qualcomm is not really late to the CPU game, but it's not that easy to just say that, yeah, we're going to be the best. Yeah, it'll be one of the CPUs. And if they can provide it at scale and at volume and, with have sufficient supply chain capacity, then people will buy it, right? So that's the level take on it.
Yeah, to your point, there is a wave happening right now, and they're missing that wave, right? Where it's just like, we need all the CPUs we can get, they're missing it. So interestingly, what happens when they come back in? Well, if CPU capacity is a lot higher, then you are going to have to compete more on performance or power or cost or something. So I guess it's good to, if you know it's going to be late, make sure that you feel very confident that you know where it slots in, which, by the way, I appreciate them calling out there's a difference in the type of workload and requirements that you need from the head node versus from general purpose, which is just running more of your SQL databases because now your agents are pummeling them, versus the agentic rack running a lot of maybe VMs with little agents, and they're spinning up tools, and some of them are making web requests and some are compiling code, whatever. So I appreciate that they spelled that out. But if they're going to try to compete at that agentic layer, yes, they need to obviously think really hard about what are the specs they want and make sure they get it right. It's too bad that they couldn't have brought it in a year earlier, but it is what it is.
There are reasons for that, which we won't get into. But I want to quickly mention also their other big angle, which is the edge AI thing, because Qualcomm is one of the biggest proponents of edge AI, other than I would say maybe NXP, because it's very important from their whole IoT and automotive business, which they've been doing for the longest time. And so they expect that what they call the software-defined vehicle is now going to be called the AI-defined vehicle. And they provided like a really interesting example. Like a car drives into a parking lot and then it sees a QR code and then it just looks at it, identifies what it is, and then pays for it, right? And you don't get like parking tickets. So if time runs out, it can renew it, or it can like maybe get an notification on your phone and then take care of it all by itself. I thought that was a nice example. Apparently, that's already in deployment. So,
oh wow,
yeah. So there's one use case they're looking at, and they want to couple these high bandwidth compute units that we spoke about into automotive SoCs, which means that you can put AI into a car, and so that it can think for itself and look at QR codes and identify this and that. And they want to put vision as a primary driver for their whole edge inference play, because they say that vision is like the biggest way to get information, and if humans can do most things with vision, AI should be able to. So they're like heavily centered on vision as a major unlock for industrial AI. So all of this was really cool because they're talking about converting cars into basically token generators. If you can have this high bandwidth compute unit in a car, it is actually using local AI inference, and connectivity may exist, yes, but you can use local AI to do a lot of stuff. And
yes,
it's really fun. I think this concept is really nice. I don't know whether it will materialize, but it's fun to hear about all these applications.
Totally. And the nuance I will add is that many cars are already token generators, but they're captive. It's for ADAS and autonomy. And so your Rivian, your Tesla, your whoever, and so you're running end-to-end neural nets these days on potentially NVIDIA chips or custom chips in the case of Rivian's RAP1. But it's captive. That is for essentially driving the car. So what's cool is essentially if you can enable the cockpit or like the user experience, user interface to have AI and have enough sort of compute headroom to go experiment and do very interesting things. Whether it's just like, hey, next song, please. You don't have to take your hands off and it actually works. Or actually the car itself doing interesting things. You.
So a lot of these edge IoT things are really fun, actually, because if you remember, they recently acquired Arduino too.
Yes.
And they have the Dragon Wing platform, which I believe they are launching later this summer. So what you can actually do is you can buy like an AI card off of Amazon, and then you can use that to run like Claude locally, right? Those are cool. I don't know what kind of model like sizes or whatever. They had said you can run Claude code locally. That's what Qualcomm said on their Investor Day presentation. So I assume it's like a capable model. But I think it's nice. They showed all these applications in like retail where you can like stock shelves and then it automatically like restocks, and you have all this intelligence within the department store, and how they use it in energy, oil, gas, and everything. But their long-term play at this moment is basically robotics, because that is what they view as their absolute future opportunity, which they mentioned to be like a $1 trillion opportunity in 2040, though. If you see
is it 2040? Yeah.
It's 2040.
So it's like, okay, whatever.
It's okay.
We'll retire by then. But no, I mean, what do you need to do interesting robotics? You need a CPU that is constrained by power, because it's probably battery powered. You need accelerators. You need memory. One of the things that we don't have today is cheap enough, high capacity, high bandwidth enough memory at the edge. So we have to run these crappy little models with very little context. If HBC or other innovations can bring us much more memory and much more bandwidth, and still do it in a way that makes sense from a power envelope, that's really compelling to be like, what if today's frontier level model, not even Fable, I miss you, come back, give me a call. But Opus level 3 or 4 years from now, if you could get that at the edge and you can fit it in, I think the opportunities are very compelling. Oh yeah, and then of course, what else do you need? You need connectivity, right? So they kind of have the whole portfolio: CPU, accelerator, some memory innovations, connectivity. It's very promising for Qualcomm. You need the software stack. They're acquiring that with Modular. Wouldn't it be interesting if they acquired it for the data center, but actually the best place for that to capture the most value was robotics in 7 years from now?
That's my whole outlook. I think we're coming up on time anyway. So I just wanted to mention that my whole outlook on what the Qualcomm Investor Day came away with was their data center entry point is a little bit late. Yes, but we are nowhere near the peak of what compute and AI is anyway. So maybe, like you say, it's just a blip in the long time horizon here. But that's a short to medium term play. I think if edge AI really becomes, something that is widely adopted, Qualcomm has a very, very strong portfolio, and they could come up and dominate edge AI like they did communications for like a good decade, right? So I think they have a very strong edge AI play, but whether that's going to come anytime like next year or whatever is the question.
It's going to take a while.
So I remember that you, in the beginning, mentioned you got to ask Cristiano a question. I don't know if it was like on recording or off recording, but doesn't matter. But now I'm curious, what did you ask him?
Yes. So it was not in the recording. I was in a room with Akash, the CFO, and Cristiano, the CEO, and industry analysts had a chance to ask questions. And this one was on the record, so I can talk about it. Sometimes it's on background, so you can't talk about it. But I basically said, hey, you introduced HBC, which needs less HBM, but more DDR. DDR uses fewer memory wafers than HBM. So on the one hand, that could shift the mix from HBM back into DDR's favor. On the other hand, this actually opens up the opportunity to bring much more memory to the edge. So, Cristiano, from your perspective, how should we think about the memory market in 28 and 29 and 30 when more supply is coming on, but new innovations like this are going to shift the mix, but also it's just going to grow the pie because the edge is going to need more. So how should we think about it? And then he was like, that was very many questions. That was a big question, but it's very good and very interesting. And I think he was basically like, HBM's not going anywhere. Don't think HBM is dead. We're going to need HBM. But he said, essentially what's interesting is the amount of increased demand there will be from the on-premise infrastructure, from the workstation on your desk to your laptop to your car for LPDDR and more memory. So he also was like giving the MOAR memory vibes, more memory.
Amazing. And in general, was everybody really excited about all the Qualcomm announcements from what you could see around you?
Oh, yeah. I think all the other analysts in the room were excited. I think, investors were excited. There's always the technical questions. Some people are naturally more skeptical than others. And so it's like, okay, you introduced a lot. You talked about it. We want to see the technical proof. And some of that is just like, you have to know the context of, this is an investor day. What are we going to talk about? How detailed and in the weeds are we going to get? And also these things take time. So, I think you can give Qualcomm the benefit of the doubt, but they do eventually need to follow up with technical details, especially if stuff's not shipping for a few years. The best thing they could do is write a paper, give a presentation, whatever, to sort of prove that at least in the lab, it's real and it works.
Yeah. So we still need more memory. Good to know.
Yes. Totally. Okay, maybe here's one last bonus thought. We won't even talk about it. We talk about it more some other time. If HBC can bring much more memory close to the accelerator. So how about, let's not call it HBC. Let's just say industry-wide, near memory compute. What are the implications on the memory market, right? Like, obviously we're still going to want HBM, but now all of a sudden maybe even more DRAM, and not even from a data center perspective, but when we're talking about bringing more data to the edge, we're talking about robotics, we're talking about cars and stuff. Like, it just feels like even more wafers are going to be needed.
More memory. MOAR.
More memory.
Yes.
MOAR. Exactly. Don't let anyone deep seek you and tell you like, oh, HBM's dead because near memory compute. No, MOAR, more memory.
All right, we should call it with that, yeah?
Let's call it there. Everyone, thanks for watching. We appreciate you curious, intelligent, interesting people who love semiconductors and listen all the way to the end. Check us out on YouTube, leave comments, check us out on Spotify, send us emails, whatever. We have a daily, if you like our takes, you can get them daily for free, semidope.com. Check it out, and thanks for listening.